So I'm David Glennon. I study energy systems at the School of Electrical Engineering and Computer Science at Oregon State University. And I'm currently working on modeling and simulation of control for wave energy converters. The Energy Systems group conducts research on power electronics, energy systems, renewable energy, motors and generators and controllers, which I'm working on now. A fuzzy logic controller, which is a nonlinear control strategy that can be useful to researchers and designers who want to incorporate a certain level of detail into the control, but maybe aren't at a stage in the development of their wave energy converter where they have the data or they need a precise representation of a final control strategy. With fuzzy logic, you get the advantage of having a linguistic representation of the control strategy that's easy to interpret for researchers or for operators. As an example, if the goal is to maximize power out of the wave energy converter, but only for a certain specified wave height, then the controller can take the response of the floating bodies of the wave energy converter as an input in terms of their position and velocity, and then make a decision about whether the force that the generator applies should be optimally damped or maybe over damped to clamp down on the movement and force the position of the device to stay within the rated range. The output of a controller would be a damping value, which would relate to the force that needs to be applied to the converter. For a finished device, there would be another level of control to get from a commanded force value to, for example, voltage to apply to a machine to get that force. In modeling the WEC, we're able to bypass that, and that makes it easier to apply a similar control method to another device with possibly a different PTO system.